Hi, you're right, and welcome to your lesson on the periodic table. So this on our first page is what we're talking about today. This is the periodic table. Even if you don't know fully what the periodic table is for, what it's about, you will hopefully recognize this from some displays around in the science room or on t-shirts, what have you. Okay, so this is what we're learning about today, and we'll develop our knowledge as we go through this lesson. To start off, you've got your three do now questions here. What is the periodic table? So put what you think it's for. Number two, what's the difference between an element and a compound? You should know that from the beginning lessons of this unit. And number three, what is a polymer? Okay, so have a go at those three questions and we'll go through those at the end of the lesson. So pause the video now to answer those questions, please. Right, keywords today are these six. These are anagrams, so the letters have been jumbled up. Pause the video to try and identify what words you think they are going to be. Lots of them you will have seen before in previous lessons. Okay, we'll go through the answers now then. So the top one was element. Second one is group. Third one is period. All jumbled up there. Fifth one is properties. Pattern is the bottom and density is the middle one. Okay, there are your keywords for today's lesson. So later on, when we're doing some of our written tasks, you'll need to try and make sure you're using some of those keywords, please. So the periodic table is this: a table of the chemical elements arranged in order of relative atomic mass. So they get larger in terms of their mass as you go from left to right and down through the periodic table. That's how we organize them. Element, as you'll know from your first lesson of this unit, is a chemical substance that cannot be broken down into simpler substances made of only one type of atom. And relative atomic mass is the mass of one atom of a given element. Okay, so each element has its own relative atomic mass. They will all be different. So relative atomic mass is the mass of one atom of that element. Key thing that we need to know about the periodic table. So the columns are vertical ones, so going down, and these are called groups. So down the top, we've got group 1 here, group 2, 3, 4, 5, 6, 7, and 0. This one at the end is sometimes referred to as group 8, sometimes referred to as group 0. Okay, now each of these different groups have different properties, and we'll go through some examples of them later in the unit. The rows, so coming across this way, these are called periods. So we've got groups coming down, periods going across. So first period just contains hydrogen and helium. Then second one, we've got lithium, beryllium, and so on. Okay, so columns vertical, they're the groups. Rows horizontal going across are periods. Right, if you can, print the periodic table. That should have been part of your assignment on Google Classroom. If not, have a look at this example. Make sure you're able to identify the three different groups. So we need to be able to identify where to find metals, non-metals, and metalloids. Most of those are relatively straightforward. The one group that can be problematic is the metalloids. So the stepped line over here, starting underneath boron, shows a division between metals and non-metals. Now, along this line as well, we'll find the metalloids. Metalloids are elements that have similar properties to metals and non-metals. So they are neither categorized as metals or non-metals. We call them metalloids instead. And they're all around this line. So we start with boron at the top, silicon, germanium, arsenic, antimony, tellurium, polonium. Now, those are our metalloids. Sometimes you will see astatine down at the bottom right here referred to as a metalloid as well, but generally it's also considered to be a non-metal because it fits into this group called the halogens. So those will be our non-metals. So for the first part of here, once you've added on your stepped line onto your blank periodic table, All the elements touching the step line, apart from aluminium here, are metalloids. So you can color those in one color on your periodic table. Following on from that, the elements on the left of the step line, all of these over here, these are metals, excluding hydrogen, top left. That is a non-metal. The rest of the elements to the left and the middle of the periodic table are metals. So there are far more metals than there are non-metals. Non-metals are found on the right of the periodic table, as well as hydrogen, and they'll need to be in a third color. So color in and create a key with the different colors for your blank periodic table. Pause the video to do this now. So your periodic table should look something like this. So we've got our metalloids in yellow down here, non-metals in green, including hydrogen on the left-hand side here, and metals in pink in the middle and on the left. So this is how we break up and separate our periodic table. The main things you need to know is where to find the metals, so on the left-hand side and in the middle, and where to find the non-metals, so these on the right-hand side and hydrogen. Okay, there are some in here which are very obvious metals, the ones that you would think of, like iron and gold and nickel. There are also some that perhaps you don't automatically associate with being a metal, things like sodium, which have slightly different properties to the metals that we think of as being metals. Okay, so next task is to sort these chemicals into whether they are elements or compounds. So your chemicals are down the left-hand side of the page here. What I suggest you do is get some paper and create two columns, elements and compounds. Then you need to list down these chemicals under one of those headings. Okay, so pause the video now to do that, and then we'll go through the answers when you're done. Okay, so in terms of elements, remember elements only contain one type of atom. So down the left-hand side, the elements that we have got, oxygen is an element, hydrogen is an element, tungsten is an element, cesium is an element, calcium is an element. All the rest are either compounds or mixtures of different chemicals. So just those ones are elements. They will be in the periodic table, so you'll be able to find their symbols to double check. Okay, next task, we're going to play a quick game of Guess Who. So write 1 to 6 in your books or on scrap paper, whatever you're working on. And they're going to be 6 clues. You need to identify what element you think it's talking about. Have your periodic table handy, or have a window open with a periodic table so that you can try and find the answers, because you will need it for some. Okay, number 1, I can be found in group 1, period 3. Remember, groups go down vertically, periods go across. They're the rows, groups are the columns. So group 1 is the first column, and period 3 will be the third row. What element will be found there? Number 2, my symbol is Fe. So find the symbol Fe on the periodic table. What element does it refer to? Number 3, I can be found in group 0, period 4. So group 0 is on the far right. Period 4 will be the fourth row. Number 4, I am often used in balloons. What is my symbol? So think about what gas is usually used in balloons, particularly balloons that float. Then find the symbol. Number 5, I am one of the elements that keep you alive. You can find me in group 6. So look in group 6, that's the 6th column. What element helps to keep you alive? And number 6, I can be found in group 6, period 6. What country am I named after? Have a look at the name of it and see if you can spot any similarities between the name of the element and a country. Okay, pause the video now to try and make sure you've got all of those answers. Have a look through your periodic table to try and help you. Okay, number 1, I can be found in group 1, period 3, that is sodium. So on the far left, the first group, 3 rows down is sodium. Number 2, my symbol is Fe, is iron. Number 3, I can be found in group 0, period 4, that is krypton. 4, I am often used in balloons. What is my symbol? The gas with helium, symbol is He, capital H followed by an E. I am one of the elements that keeps you alive. You can find me in group 6, is oxygen. And number 6, I can be found in group 6, period 6. What country am I named after? Poland is the country. So the element that you were looking for is polonium, which was discovered by Marie Curie. And she was from Poland, hence it's named after Poland. Okay, so there is a very glaring mistake with how this chemical symbol has been written. This should be the symbol for silver. However, you can see that here it started with a lowercase a followed by a capital G. It always starts with a capital letter. For some elements like carbon and oxygen, it's just a capital letter on its own. But for some, it's a capital letter followed by a lowercase letter. So silver, for example, should look like this. So it should be a capital A followed by a G. Excuse the handwriting, I'm using a mouse. Okay, so always a capital letter first, followed by the lowercase. So a quick recap on what we've covered so far. Periods are what goes across. They are the rows going across the periodic table. It indicates how many electron shells, energy shells, an element has, and they show patterns in the properties of elements. So we can spot patterns by looking at the periods as well as looking at the groups, but they are what goes across in the row. Okay, the groups are the columns going down. These indicate how many electrons are in the outer shell. They are put in the same group if they have similar properties. They show a pattern of reactivity. So, for example, group 1 is a group called the alkali metals. It's on the very far left of the periodic table. And these elements all are very reactive metals. Okay, excluding hydrogen at the top. And the reason they are so reactive is because they only have one electron in their outer shell that they want to get rid of. Okay, so they all have similar properties, and as you go down that group, they become more reactive. Okay, your next task, you will need some paper. If you have squared paper or any graph paper, that would be ideal. Otherwise, this might be a bit of a rough graph. So you have 2 sets of data here for period 2 and period 3. What I'd like to do is to create a bar chart to display this data. Then write a sentence to compare the atom size patterns for period 2 and period 3. So what happens to the atoms as you go across the periods? So here, use your bar charts, write a sentence to compare the atom size patterns in period 2 and 3. Predict the atom size of the missing elements from both periods 2 and 3. Add these to your bar charts as well. This is where we need to make sure we're using some of our keywords. Describe the trends in the periodic table. Use the keywords density, reactivity, atomic size, groups, and periods, please. Right, do this now, and then we're going to have a look at how you would mark your own work. So we're going to look at what the expectations will be for your graph and for your answer following that. So for each graph, can you give yourself a mark out of 5? If your x-axis is labeled with elements, that's 1 mark. Y-axis, so going up, is labeled with atomic radius in nanometers. So we've got our units here as well. If you've used a ruler and a pencil, you get a mark. Easy one. Bars plotted in the correct place. Missing element has been added at a value between the two on either side of it. So it doesn't need to be precise, but it needs to be somewhere between the one to the left and the one to the right. For your question, so write a sentence to compare the atom size patterns in period 2 and 3. Generally speaking, the atomic radius decreases as you go across the period. However, oxygen does not fit this trend. Atoms in period 3 are larger than those in period 2, except for chlorine. Okay, so it doesn't require any explanation. It's just about comparing and identifying some of the trends that you can see in the data. Okay, so look carefully when you're answering this sort of question. It doesn't ask you to explain anything or analyze. It just gives you the keyword compare. Okay, so you're just looking at what's the same and what's different between these two sets of data. Hopefully you'll be able to answer this question now. So how can we use the periodic table to identify metals and non-metals? If we think back to the periodic table we've drawn, you would remember your step line starting underneath boron and going down and across like this towards astatine at the end. So elements to the right hand side of this step line are the non-metals, to the left are metals excluding hydrogen, which is a non-metal, and those touching the step line, excluding aluminium and astatine, are our metalloids. Okay, but non-metals on the right hand side, metals on the left hand side. And finally, number 3, a polymer is a large molecule composed of smaller monomers. So polymer is a very large molecule. All right. I hope this lesson has been useful to you. If you have any questions about any of the content covered here, email your teacher and they'll get back to you. Okay. Good luck.